Once again, let's have a look at this example from the Basic Econometrics book by Damodar Gujarati. This is the regression results based on a sample of 64 observations. Our dependent variable or y variable is Cm, which is child mortality, and the two independent or explanatory variables that we are considering in this model is PGNP, which stands for per capita GNP, and FLR, which stands for female literacy rate. So this was the regression result obtained when the analysis was done in an EViews package with an EViews package. EViews is a statistical software which can be used to run regressions and many other statistical analysis. So let's just see. Just a second. Yeah, so the model that the model that was estimated was beta 1 hat plus beta 2 hat per capita GNP plus beta 3 hat female literacy rate plus UI hat. That is the estimator of the population disturbance term, that is UI hat. So this was the model that was estimated, and those are the results that we got. If you look here, so the value for beta 1 hat is 263.6416. The value for beta 2 hat is minus 0.056, and the value of beta 3 hat that was estimated from the sample was minus 2.2316. The second row shows the standard errors of each of these variables. In one of the previous video lectures, I had shown you the formulas for these for the standard errors, right? It is the square root of the variance term, and I think I had discussed the variance formulas with you. The third row contains the t-values of each of the coefficients when you are saying that the null hypothesis is beta 1 equal to 0, beta 2 equal to 0, and beta 3 equal to 0 respectively. The fourth row is the p-value. Remember, the p-value means the exact level of significance, or it is the minimum level of significance at which the null hypothesis can be rejected, right? Like I had said earlier, if you have a level of significance that is already determined called alpha, that is the probability of committing type 1 error. Say you have fixed alpha at 5%. Compare it with the p-value. If your p-value is lesser than 5% or lesser than 0.05, then you can say that the partial regression coefficient that you're considering is significant. Right? You're saying that because the null hypothesis is rejected. So as you can see, all three of the coefficients, beta 1 hat, beta 2 hat, and beta 3 hat, are significant at 5% level of significance. We also have the R square value, which is 0.7077, and the adjusted R square value, which is 0.6981. So adjusted R square value is the R square value adjusted for the degrees, adjusted by the degrees of freedom of each of the sum of squares that appears in the formula. And R square gives an indication of how much variations in child mortality, how much of the variations in child mortality is being explained by variations in the per capita GNP and female literacy rates. So according to this model, the R square value of 0.70 means 70% of the variations, or 70.7 can be rounded off. Nearly 71% of the variations in child mortality can be explained by variations in per capita GNP levels as well as female literacy rates. Okay. Now, besides that, I want you to pay attention to the value of the estimates. So when I say that beta 2 hat is minus 0.0056, I mean to say that if per capita GNP changes or increases by say 1 unit, the child mortality will come down by 0.0056 units. Okay, I am saying that when PGNP increases, CM will come down because the sign of the coefficient is negative. A negative sign means that PGNP of the coefficient means that PGNP and CM, that is child mortality, are negatively related or inversely proportional. Similarly, a value of minus 2.2316 for beta 3 hat means that if the female literacy rate goes up by 1 unit, child mortality will come down by 2.2316 units. Once again, I am saying that when female literacy goes up, child mortality will come down. That is, there is an inverse relationship based on the fact that beta 3 hat has a negative sign. Right? So that is how you would read this output table. Now, moving on,